Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We're here live at Seibert Elementary School, home of the Raiders, and today we're all here to do that!
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Marylou. You need help with your homework tonight? We have tutors here till 5:30. Give us a call at 636-4357. If you're calling from San Luis Obispo, you can call us at 1-866-636-6284, or you can email us your questions at dothemath@kern.org. Or you can find us on social media at Facebook, Instagram, Twitter, all that wonderful stuff.
All right, and speaking of the social media, we need to shout out to all of our associate producers that take care of all of that social media, because they do an outstanding job with all of that, because there's a lot of different things that we're on, and they're updating that all of the time. So kudos to them.
And they always make me look good. So.
And well done, so nice job. Anyway, we do have phone tutors available until 5:30, as we do most Tuesdays and Wednesdays throughout the regular school year. And we do have about, I think, like a 10 or 11 week run where there are no holidays, no Thanksgiving, winter holidays, anything like that. So we're just going to go until, I think it is when the time changes, when we do that spring back or spring ahead or whatever it is. So that's when we'll be ending about them. Yeah. We have a very special guest in the studio with us this afternoon. We have a 6th grade student. We also will be going back out live to Berkshire Elementary. And before we do any of that, let's first take a look at today's Math in the News. And my mistake, we are at Seibert Elementary today, not Berkshire. I thought we were, I think we're going to Berkshire next possibly. Maybe that's what I had in my mind. But anyway, we'll be out to see the Raiders of Seibert in a little while. Anyway, today's Math in the News. You know what happened yesterday?
What? Nothing.
Well, something happened. Can you tell me anything that happened yesterday? It doesn't have to do with just anything that happened. Anything big in your life happened yesterday?
No.
Anything at school happened yesterday?
The wind, it was really windy.
There you go. See, it was a really windy day in Bakersfield yesterday, right? Kids were flipping out, going wild, because, and it's nice just to have weather and clean out the air in the valley.
This is true.
Where you can actually see more of the valley and the mountains and everything around.
Yeah, it's beautiful.
And a little bit of rain, not too much, and then today just a little bit also.
Yeah.
Just something to clean out the air a little bit. But anyway, in today's newspaper was a photo from yesterday with students going to Bakersfield College for the first day of the new semester. And I figured, well, they're showing us a photo of them going into the mathematics building. So of course, with them going into the mathematics building, I had to do something with Bakersfield College and this photograph. So here is a problem that most of them might be presented with as they are going to Bakersfield College. So let's see, we'll, might not be able to get all of that. Okay, here we go. So we've got a red figure.
Yes.
All right, and we've got obviously a square up there that measures a 4 by 4, but it's broken into 2 by 2s. And we have some different options: 8 minus pi, 8 plus 2 pi, 8, and 8 minus 2 pi are the options for our answers. And we want to know the area of the red figure. And all arcs shown are of circles. So When we take a look at this, is there a way that you think you might attack this? Like when you first saw this, before we kind of went over it, what was your first plan of attack?
My first plan of attack was obviously tackling the square, finding the whole entire area of the square, and then going from there using the knowledge that I know of area of circles,
Right.
subtracting that.
And we know the area of a circle is pi r squared.
Yes.
Right.
What's a mathematician's favorite dessert? A square pie.
Well, of course, and pumpkin pie, I mean, all these different things, right? So a lot of things we do with that. That coming up on Pi Day later on in the year. Anyway, so let's take a look at this once again. And so some of the kids and those of you working at home, looking at this, you've got another 5 seconds I'll give you. And even if you're not really sure, take a shot,
Yeah.
see if you can guess which one that is, and then we'll go ahead and reveal how to solve this problem. And here, we can see, we'll get rid of those 2's up there. We know what they are, all right? So if we combine the bottom left square with the top right square, we get a complete red square, okay? So you can see how they're moving the lower ones to the upper ones. Combine the bottom right with the top left, we get a complete square. Now the whole thing is 16 because it's a 4 by 4 square.
Yes.
But we want to know the area of the red. That is only half of it, so that would be 8.
8.
And there's your answer right there, and that is today's Math in the News.
That reminds me of like a trapezoid. How moving.
Right, so you
sides?
can take one part, move it
Yes.
over, and it's easy to figure out like that.
Exactly.
All right, 636-4357 is that phone number. We do have phone tutors available until 5:30 this afternoon. In studio with us right now, we have Julie. How are you today?
I'm good, thank you.
Why don't you remind everybody where you go to school and what grade you're in?
I go to Reagan Elementary and I'm in 6th grade.
How long have you been at Reagan?
About 7 years?
So you've been there since the beginning of your schooling.
Yes.
So since kindergarten. You think you're going to miss it next year?
No.
No?
No.
What are you looking forward to then?
Electives.
So do you have an idea of an elective that you might want to take next year?
Possibly computer or chorus.
Oh, good. So are you doing chorus right now in 6th grade?
Yes.
Okay, so that's something that you could go into and be comfortable with.
Yes.
And why do you maybe have computer as an option for an elective next year?
Because obviously in high school we're going to be using our laptops a lot, so I just want to get faster on the keyboard.
There you go. Well, you know what? Those are 2 very good electives to have an option for right there.
Thank you.
Everything's cool with 6th grade?
Yes.
All right. You ready to do some work?
Sure.
That's what you're here for. Let's go over
Come
to the
on,
board.
kiddo.
All right. Actually, what we're going to do right now is we're going to work with some fractions. So, Marylou, why don't you come up with a fraction? Not a mixed number. I want a fraction. Not.
Okay.
All right. And Julie, why don't you come up with another one? Now, what I'd like you to do is multiply those.
Okay.
Okay. Kind of talk me through this. What's your strategy?
Okay, so usually I would do cross multiply, so if they're like the same I can go ahead and simplify them, but in this case I can't do that. So I'm just going to multiply from top to bottom. So 3 times 2 is 6, and then 5 times 5 is 25.
And Julie, can you simplify that at all, or is that it?
I think that's it.
Yeah. I think you are correct.
All right, so now what I'd like you to do is, because you guys had no idea what I was going to have you do,
Yeah.
right? So what I'd like you to do is rewrite those again underneath 3/5 and 2/5.
Okay. I'll let you do it. Go ahead.
Now, instead of multiplying them, we're going to add them.
Okay.
So now how is this going to make it a different problem?
Because instead of multiplying, which would give you double digits, you would just go ahead and add the 2.
Okay. What is the difference between multiplying with the denominators versus adding and subtracting with the denominators? What's the difference?
The difference is because basically you would just, when you're multiplying, you would get obviously a higher number because you are taking the number and then whatever other number you have that you're multiplying by, you would just add it more to it.
Okay, but I know that our denominators are the same here.
Yes.
Okay. When we are adding, though, and subtracting, can we have different denominators, or do our denominators always have to be the same?
You can have different ones.
Okay, so if I have, what if our problem was this? Instead of 3/5 plus 2/5, now we have 3/5 plus 2/7. Can we just go ahead and go 5 plus 7?
No.
So what's the difference between multiplying with our denominators and adding with our denominators?
You would have to find a common denominator.
Exactly, and that is a common mistake with a lot of students, whereas personally, I think multiplying is so much easier because we don't need to find a common denominator, do we?
Yeah,
We just worry about multiplying the numbers. Whereas here, we have to have a common denominator, don't we?
yes.
Okay, Julie, I'll let you finish out this problem.
Okay.
So now, let's look at our answers. Here, our answer is 6/25, but here our answer is 1.
Yes.
What difference do we see here?
Well, we have a whole number and then we have a fraction.
Which is larger?
The whole number.
The whole number is larger. Something to think about, huh?
There you go. Well, nicely done for that right now, ladies. We can continue on that in just a little bit. But right now, we do have an opportunity. We're going to go out and visit with our friends from Science for Kern. They're at Seibert Elementary.
Hey, thanks a lot, everybody. Back here at Seibert Elementary School, it's Science for Kern Challenge Day here on Do the Math. I'm here with Michelle from Science for Kern. Michelle, great to see you again.
Good to see you too, Devin.
For those of our viewers joining us for the first time, explain a little bit about Science for Kern and as an organization, what it provides for the students here in Kern County.
Sure. Science for Kern is a science mobile lending library for schools around Kern County. Focuses on 4th and 5th grade science curriculum. The program comes with all the materials, teacher's manual, worksheets, everything that the teacher needs to teach a science unit. And there are 8 science, different topics for teachers to choose from. And the materials can be checked out online at scienceforkern.org.
So how do these lessons differ from what teachers might traditionally think of a science lesson as far as worksheets or memorizing names or vocabulary?
The activities are very hands-on in focus, as well as NGSS aligned. The creator of the program has tried to align the hands-on experiences with the next generation science standards, as well as building critical thinking skills in the students as they go through the hands-on lessons. The lessons are super engaging and a lot more fun than just pulling out the old science book and digging into the worksheets.
Well, we could talk about them all day, but I think what our viewers really want is to see it in action. So we've got a wide range of students here from Seibert, and our raters here are ready to go, up for the challenge. And without further ado, Michelle?
Yeah, our challenge today is we have been talking with the students about the challenge before going live on camera. And our challenge today is to build a 4-wheeled balloon-powered car out of the materials that they've been provided in the bag. Things such as straws and an empty water bottle and some bottle caps. They have tape. The students have tape and scissors to use as tools to help assemble the car. And the constraints of the engineering challenge today are these 2 constraints. Number 1, our first test will be if the car can go 12 inches on here's our 12-inch track. And the second constraint is that the car needs to go straight. And the students have had a chance to talk a little bit about their plan. So at this time, they're super eager. Let's go ahead and open the bags. All right. So students, you had a chance to talk before we went live on camera. How about if somebody shares with us your plan? What are you thinking you're going to do?
We were thinking of cut put it together and then use a straw to put it in the balloon.
Okay, so you're going to put the sponge inside the cap. What purpose will that serve?
So the cap's not gonna fall and
Okay.
should be stick.
Okay, going to be what? Say that one more time.
Still, like.
Oh, so it will be still. And what will these caps be like if it were a real car?
Wheels.
All right. Well, we'll check back and see how you're doing. So, what's your plan, ladies? Tell us about what how you're planning to use the materials and why.
Okay, so we're planning to use the bottle and stick the sticks inside of the water bottle and put the wheels on it and put the sponge in the middle next to the water bottle so it won't go. It won't go
wobbly?
Yeah, it won't
the
go
word you're
wobbly.
looking for?
And then we're gonna stick the balloon and we're gonna stick the straw with the balloon and then put it inside and use the tape maybe to tape on the wheels.
Okay. Well, we'll check back and see how it's going. All right. So, what's your plan,
Okay,
ladies and gentlemen?
So our plan is that we're gonna grab one of these or something that we could find, and then we're gonna use this to let it hold for the thing so it can go, and then we're gonna add our balloons, and we're gonna use our tires that are supposed to help us move, and then we have straws.
What will you do with the straws?
We're gonna put it inside the balloon and blow. So then we don't have to like hold it or something.
Okay. All right. Sounds like the beginning of a great plan. So, what's your plan over here?
My name is Sophie.
Hi, Sophie. Tell us about your plan.
So we're gonna make well, my friend Gabriel here is trying to make like air experiment plans. So like we're thinking that we should put this into here, and then we do this to poke each hole with it,
Okay.
and then
So tell me about the holes. Are there holes in that water bottle?
Yeah, there's already holes, so we can use these
Okay, can you show the camera where the holes are?
right there.
Okay.
Those should be on both sides.
All right. And then there's one on top, right?
Yeah, and then there's also one here. There should be another one here.
And we have the scissors, so if more holes are necessary, they can open them up themselves with the tools that they've provided. A lot of different approaches. You see a lot of students using those caps as kind of the foundation because of the number. They think car, they think 4 wheels, and there's 4 bottle caps. But it's interesting to see some of the other approaches that we're seeing take shape. So when we come back, we'll see where our designs are, and we'll go from there. But for now, we'll send it back to the studio. Mike, Marylou, take it away.
All right, thanks for that, Devin. Nice to see Michelle out there working with the kids from Seibert Elementary. We do have phone tutors available until 5:30 this afternoon, and also don't forget toll-free. The number's at the bottom of your screen periodically throughout the program. We have a 6th grade student, Julie, in studio with us right now, working with decimals currently, but you're comfortable with fractions.
Yes.
So why don't you go ahead on over to the board? I've got another one for you to work on.
Okay.
So before we multiplied and added some fractions, I'm not going to give you the choice of what you're putting up there now. 6 3/4
Go for it.
divided by 2. So if you would solve that problem and explain it as you go along.
Okay.
Okay, what's the most important thing that we need to do first?
Change this into a mixed number.
Absolutely. We can't multiply or divide with mixed numbers, can we? We have to have it in fraction format. Okay, so Julie, how do we change that to an improper fraction?
So you would do 6 times 4, which is 24, and then add 3. So it'd be 27 over 4.
Okay. Okay, what's the next step?
You could put a 1 over the 2. Or
Okay.
a 2 over the 1.
Okay, so we are going to put a 1 underneath that, correct?
Yes.
Okay. And we have our division, right?
Yes.
Okay, so are you ready? Can you go ahead and start dividing it, or is there still one more step?
You have to change the reciprocal.
Very good. Which is the reciprocal? Am I going to do the reciprocal with our first number or our second number? This is our dividend and that's our divisor.
So it would be the second number.
Okay. So we know that this is the reciprocal. Anything else we need to change?
Multiplication sign.
Absolutely. Go ahead and rewrite that for us. And this, Julie, is a common mistake a lot of students make, is that they want to do the reciprocal of the dividend.
Yes.
Or they want to do the reciprocal of both, the dividend and the divisor, right? But we know that we're always only focused on
The second number.
yes. Okay, where do we go from here? Oh, real quick, another question. Could you, because you talked earlier about cross simplifying,
Yes.
can we go, I see right here, I know that 2 is a factor of 4. Can I cross simplify right now?
You could over here, but since we changed the reciprocal and changed the division into multiplication, we can't.
So yeah, so we don't want to do any simplifying at this step, do we?
Yes.
So what you're saying is that you want to wait until we get to?
Multiplication.
Okay, keep going, kiddo.
Okay, so
Okay, are we done though?
no, not yet.
What
I
do we
would
need to do?
argue, yes, you are.
Okay,
Now,
however,
that's right. That's why I wanted to bring that up. So I want you guys to talk about both,
okay.
okay?
You are and you aren't. Why? Do you know why?
Right,
According
because
to
in 6th grade right now, which is why she may not know she is finished yet.
okay. Okay, so according to where you're at, this is done.
Yes.
Okay. However, when you move on with your grades, you're going to jump to another step. You know how to turn a mixed number to a fraction.
Yes.
Do you know how to turn a fraction into a mixed number? That's the next step. So where you're at, you're done.
Yes.
However, when you go on next year, this gets turned back to a
Mixed number.
mixed number. Now, what does that division bar really mean? Do you know what operation? Does it mean add, subtract, multiply, or divide? Do you know what that bar really means? No. It actually means division. That's the operation. So what I'm looking at is really 27 divided by
8.
8. You know how to divide, yes?
Yes.
Can you divide, put 27 in the house and 8 outside? And divide that for me with a remainder. I want a remainder though. I don't want you to keep going with the decimal. I want you to leave a remainder. Okay, talk me through this.
Okay, so 8 goes into 27 3 times. So we just put a 3 over the 27, and then 24. And then 7 minus 4 is 3, and then 2 minus 2 is 0. So you put 3, and then
You just did it. You just turned this fraction into a mixed number. And now what I said is we need the remainder, okay? That's important. So what we're saying is we know that 8 can go into 27 3 complete times, right?
yes.
With 3 of the 8 left over for the next part of it, right? Because fractions are part of a number. So there you go. You're already ready to go. Good
Nicely
job.
done. So I knew that she would be able to go to the mixed number.
Yes.
What I wanted her to realize is that you can leave it as an improper fraction because when you go to junior high, those are going to be acceptable answers.
Yes, especially in 8th grade, once you get more into algebra, your teachers are going to want this left.
Right.
And there's a reason behind that.
So that's why I wanted you to go, yes, it is completed now, so that you can leave it in either form. But I know that in elementary school, they probably have you automatically going to the mixed number, right? Okay, but either way is correct. Hey, we do have phone tutors available until 5:30. We'll be back with more right after this. Today we're at Richgrove Elementary School, home of the Warriors, and we're here to... Well, today we're at Richgrove Elementary School. We've got some 4th, 5th, and 6th graders. And they're going to be working in pairs today, and what we're going to have them do is, first of all, look at some patterns with numbers, specifically on the 100 chart. A lot of students use this when first learning their times tables and looking at patterns for certain numbers. So what I want you guys to do is take a look at the chart that you've got, and you can do it individually right now if you want, or you can work together with a partner. What I want you to do is just find a couple of patterns, all right, other than 1, 2, 3, 4, 5, that's a pattern, right? But what I want you to do is I want you to find a pattern and then be able to explain the pattern to us, all right? So you can make little marks on your paper if you want to remind you of what the pattern is that you're doing. So if I did a pattern like this, if I said, all right, I'm going to start at 1 and I want to add 1, where am I? I'm at 2, right? Okay, so now I'm at 2. I added 1 before, and now I want to add 2.
4.
Now I want to add 3.
7.
Now I want to add 4.
11. 11.
You see, you can make up any pattern you want. All right? So look at the chart, and you might be able to see something, and you're like, ooh, how does that work? Like if you were looking at something diagonally, if you wanted to make a shape of something. So take a look, see what kind of patterns you can find, or a pattern you can make up on this paper. So what pattern have you got going right now?
So it's practically that by the 2s, but I didn't start here. I started at 12, and then I'm adding 3 so I can go to 16, so it could be even numbers.
Okay, so you're going from 12, you're skipping 3 of them, including the 4th one, so you're counting by 4s right now?
Oh yeah.
So you're doing it by 4s. All right, so go ahead and you can shade in a few more. And why did you start at 12? Just you didn't want to do the first row?
I didn't want to do the first row because I felt like that was too easy.
Okay, good, so keep on going. Have you got a pattern?
Yes.
What's your pattern?
My pattern is I'm doing by 3s, by 4s, and by 5s, and by a 1.
Okay, so you go count by 3, then by 4, then by 5?
Yes.
Is that what you're doing? So if you went 3.
So I could get to the even number 30.
Okay.
So I started through odds, and so I went to evens.
All right. That's your pattern. And what have you got going on?
Like 3s.
You're going by 3s? All right. And what have you got?
I'm multiplying by 11.
So you're going by 11. So everything is a double, right? Where you've got 1, 1, 2, 2, 3, 3, 4, 4. So that's a good pattern right there. And let's see, our final pattern, what have you come up with?
I'm doing it with 5 4s, but at first I was doing it by 2s, but I decided to make it by 4s.
Oh, so you started with 2s and then you decided to go by 4? There you go. Well, it's your pattern. You can decide what you want to do, all right? So that's just a little bit of the introductory work for the 4th, 5th, and 6th grade students at Richgrove Elementary. And once again, a big thanks to the staff and students out there at Richgrove. We had a wonderful time. The students working on patterns. We'll find out what they did. More with that in just a little bit. We do have phone tutors available until 5:30. We have Julie, a 6th grade student from Reagan, in studio with us right now. And we have another opportunity to head back on out to Seibert, visit the Raiders, and see how they're coming along with their science projects.
Thanks a lot, Mike. Back here at Seibert Elementary School, we are right in the throes of the Science for Current Challenge, and everybody is right in the thick of things. We have a lot of unique designs coming about, a lot of similar ideas surfacing, and then one really clever adaptation comes, and all of a sudden it spreads like wildfire.
Yeah, there's an awful lot of table groups watching table groups and learning from each other as we go. Yeah.
Definitely
exciting.
open, so let's open ourselves up to some of these designs and thought processes.
All right, so let's go back to this group here and have them explain to us a little bit about what you've been working on and tell us a little bit about why.
So we cut the sponge into little tiny squares, and we put them in right here and try to fit it in, and we take one of these and skewers and stuck them in there and put it in here so it'll go like.
Okay, so you're going, show me, demonstrate for me.
So basically we're gonna put it in here and we'll think it'll roll better because it goes like that and it rotates.
Ah, okay, so interesting observation for me as I'm getting to watch the other groups. You're one of the first groups who, the other groups had just put the bamboo skewer alone through the holes in the water bottle. And when you tried that, before using the straw, what happened?
It still rolled, but it didn't roll as well.
Okay, so what purpose do you think that this straw on the outside with the bamboo skewer inside, what purpose do you think that serves?
Because it pushes the straw to go more.
Tell me, keep going. What do you mean by that?
Because the straw helps it rotate.
Ah, okay. That's an interesting addition to the design. So what do we have going here?
We're trying to get that sponge to go in these holes right here,
And then why? Why are you doing that?
for the wheels can hold up. We can hold the wheels up.
Okay, so you want to stick the bamboo skewer into the wheel? Okay, so how about if you try it out? Put the sponge in there and see if it will attach to your wheel. Will it hold there? Or do we need a bigger piece of sponge? All right, so how about if I leave this new piece of sponge here? I've been working with this group earlier, and their sponge, just a design flaw, their sponge was too hard. So I've brought them a softer piece of sponge, and we're trying that out to see if it makes a difference. So we'll have to check back and see what happens.
One of the other interesting things too is if the challenge is keeping the sponge in the bottle cap, is there a material that could help keep things in place that the skewer would be able to go through? So, again, reevaluating and thinking about the materials that you have to solve the problem that you've identified. Let's take a look at another group back over to this side here.
Let's see what we have going at this table. Ah, I notice a similar design. Tell us about where you're at now with your design and build.
We're going to be putting on the wheels.
And so tell us about your putting on the wheels strategy.
We're going to be putting tape on it.
Okay, so we were talking about how, the tape provides a solution for the sponge in the wheel problem. So, you have the tape, and how are we applying the tape in order to keep the sponge attached to the wheel?
I guess we're going to be putting it above it so that we could stick these in and the sticks will stay so that the wheels won't fall off while it's moving.
So what happens when you stick the wheel with the sponge onto the ends of the bamboo? Does it stay?
No, it doesn't stay. It doesn't work.
Okay.
Even if you press and twist it in, it doesn't stick.
No.
Okay, and that's where the tape might provide the solution.
Yes.
Get it to stay on there. All right, so we're going to let you work on that a little bit
Now,
more.
We also have a group that is starting to really consider the propulsion part with the balloons and how that might apply.
Ah, very nice. So we've got two wheels here. What's missing on your design there so far?
So additional wheels. One of the challenges I noticed that you're kind of playing around with is, okay, we've attached the balloon to the straw for propulsion. Now how are we going to inflate the balloon? Blowing that balloon up through that straw has posed a bit of a challenge, right? So one of the things that we're noticing from this group now is how do we address that challenge of inflating the balloon now that we've attached it to the car?
Right. Okay, so what else are you going to add to your car?
The two other wheels we need. And then one problem that we did have was that for the balloon, you have to be careful because it might have a little hole, because you know how you just put tape on the front right here?
Yeah.
It might have a hole coming out from the sides, from the other sides.
So to make your balloon airtight. So interesting interesting difference to your design are these sponges here. Why did you choose to put those there?
Because we knew how it was going to wobble when it was going to run, so we decided to put the sponges there so it won't wobble while it's still going.
So they're using spare sponge pieces as dampers, almost as shock absorbers
Right.
on the undercarriage there. Again, like these are things that we start to see in like mechanical real-world cars that engineers have designed and put in explicitly to solve the exact same challenges that these students have faced. So we're going to continue with our challenge, and when we come back, we're going to test things out and see how well we're ready to go for our trials. But for now, we're going to send it back to the studio. Mike, Marylou, take it away.
All right, thanks for that, Devin. Can't wait to see the races and how far these things go.
Pretty
so we'll check
exciting.
that out in a little bit. All right, young lady, you ready to work again?
Yes.
All right, let's keep the same theme going with mixed numbers, fractions, and things like that. This one's going to be a little lengthier. All right, so you're going to want to start over on the left-hand side. 3 1/2 minus 1 5/6 divided by 1 2/9. Now you need to remember the order of operations also along with solving the problem.
Okay. Okay, so PEMDAS.
Yes.
All right, what do you think we need to solve first?
Well, according to PEMDAS, the division.
Very good. What error do you think students would make?
They probably wouldn't change the mixed number into a fraction, possibly.
Okay. According to PEMDAS, where do you think they'll start? Do you think they'll start with division?
Probably not. They might start at the left side because of a normal equation would be like that.
Exactly, but with your help, they're not going to do that, are they?
Yeah.
They're going to start here. So I'm going to let you go ahead and tackle this problem.
Okay, so first I'm going to change all of the mixed numbers into normal fractions. So starting all the way here from the left, so 3 times 2 is 6, and then plus 1 is 7. And then this one right here would be 11 over 6.
I'm going to throw in the minus sign there for
Feel
you.
free. And then right here, 1 times 9 is 9, and then plus 2 would be 11. So you have 11 over 9.
Okay, so now what are we going to do? You said divide first, right?
Yes.
So let's go ahead and tackle that first.
Okay.
And would it help, Julie, if maybe we add parentheses to where we could see where we need to focus first?
Yes, possibly.
Okay. It brings our eye, right? Knowing, hey, I know I need to focus on that first.
Yes.
Okay, go ahead.
Okay, so 11 6 divided by 11 9. So first, we're going to go ahead and turn that into multiplication.
Okay.
So I'm just going to bring it down here. And then we're going to change the reciprocal, so it'd be 9 over 11. And then since I like to do cross multiplication here, we can just change these into 1.
Why are you changing those to 1?
Because 11 divided by 11 is 1.
Perfect. Is there anything else, Julie, you can change? You can simplify?
Nope.
Is there a common factor with 9 and 6?
Oh yeah, 3.
There you go. So we can divide both of these by 3.
Yes.
Okay. Okay, now what's our next step?
Next, we multiply.
Okay.
So that would be 3 over 2.
Okay, so now we have the division part. Now we need to go back to our 7 over 2, right? And incorporate that. So we have our 7 over 2 minus 3 over 2. And do we need to find a common denominator?
Yes. Well, we don't already have. So.
Why? Why don't we need to worry about that?
Because we already have a common denominator.
Okay, finish this off for us.
Okay, so and then we subtract, so it would be 4 over 2.
And again, yes, in junior high, that's a perfect answer, but can we also simplify this?
Yes. So 4 divided by 2 is 2, and then 2 divided by 1, or 2 divided by 2 is 1.
And can I go even farther with that?
Yes, so it would equal 2.
Perfect. There you go. And real quick, I want to make sure so everybody understands how you simplified. You divided both numerator and denominator by the same factor.
Yeah.
Good job. Nice, nice.
Well
Okay.
done with an answer of 2. You've got yourself 2 tickets to any CSUB athletics event you would like to go to, courtesy of the athletics department at CSUB. And there are a lot of things going on right now. Basketball, do you like basketball at all?
Yeah, I actually play for the Reagan team.
Oh, good. Well, you know what? You might be able to head on out to Cal State and watch one of the basketball games, men's or women's. There's also wrestling going on, swimming, diving, baseball coming up. A lot of different things going on. So we hope you'll have an opportunity to go out and check out one of the sports. We'll be back with more right after this. Today we're at Richgrove Elementary School, home of the Warriors, and we're here to... All right, this time at Richgrove Elementary, we've got the same 4th, 5th, and 6th grade students. They've been working on patterns of numbers, coming up with their own particular patterns, and they've got the numbers 1 through 100 to work with. So now what they're going to do is they're going to work in pairs and have to find a specific number based on the clues they're given. So, pick a card, any card. There you go. Take it apart, go ahead and start doing it. Pick a card, any card, what do you like? There you go. All right. Since we have the young lady over here, you get your choice. All right. Take the clue cards apart, look at them all together. Working in your pair, you want to find the one specific number for each of those sets of cards. So we'll let the kids go ahead and get started on this, and we'll see what they come up with.
I'm probably gonna do like 1 times 5, like 5s, like 10s, 15s, 20s, all of that.
It's 2, 4, 6. How do you find whole number 100? Whole number is not an even number.
Now make sure you know the vocabulary that's on the cards, because if it's asking for the sum of something, what do you have to do?
Add it.
You have to add them, right? If it's asking for the product of something, what do you need to do?
What's added to 1.5?
So if you're going to find the product, you're going to multiply the 2 numbers, right? The sum is you're going to add them. If you want to know the difference of 2 numbers, you'll have to subtract them. Let's take a look. 84, okay? So the sum is greater than 10. What is the sum of that?
15, 18.
8 and 4 is?
84 is...
What's 8 plus 4?
8 plus 4 is 6, 12.
12. Is 12 greater than 10?
Yeah.
Okay, so that's set. The number is not odd. So that means it has to be even. Is that an even number? Yes, right? Okay. The first is larger than the second. So is 8 larger than 4?
Yes.
Okay, so that works. Both of the numbers, both of the digits are even. Is 8 and 4 even?
Yes.
Yes. The difference between the 2 numbers is greater than 3. So what's the difference between 8 and 4?
They're both greater than 3. 8.
Well, if you go 8 minus 4, 4. And is that greater than 3?
Yes. Yes.
Yes. It's a multiple of 7. How many times does 7 go into 84?
80.
So go 84 divided by 7. If you need to work it out on the paper, you can. So go 84 divided by 7 to make sure that this works. All right, so work it out on your paper if you want to. So 84 divided by 7. Let me know what that is, and then we'll see, because that's the last clue, and if it works, you found the number. You guys did an excellent job. So how many times does 84 divide by 7?
7 times 12.
So it's 12 times, right? Nice work. You guys found the number first. There you go. Well done. Nice job. All right, so the kids are working on finding their numbers at Richgrove Elementary in 4th, 5th, and 6th grade for the patterns 1 through 100. And that's all most of this is patterns and looking for that pattern. Hey, we do have phone tutors available until 5:30 this afternoon. We have a young lady, Julie, in studio with us right now. And we're going to take a peek out to Seibert Elementary and see how the Raiders are doing with the Science for Kern mobile that they are working on. And it looks as though they're getting pretty close to the end of this. And we can see some of the students, they're figuring out how to attach their wheels. I think some of the groups were having a little bit of difficulty making sure that those stayed on. And once they're on, whether or not they're going to actually rotate, move, roll, and be able to propel.
I'm anxious about the balloon part of it.
Right, how they're going to get that
Inflate
thing
the
to
balloon,
propel and
yes.
get that going. But I have all the faith in it. So there we go. Some of the students working on it right now. Yeah, it's going to be quite interesting to see how far they want to extend from that balloon opening to try to fill the balloon. But that's part of the fun of this, is to see what kinds of solutions they come up with. And we'll visit with those guys in just a little bit. But we'll go back and see how that all turns out at the end right now. All right, young lady, we are done with the fractions and stuff. Are you done with those?
Yeah.
You done? You good? All right, head on over to the board. Now, I know this is one thing that you've been working on in class. It was just introduced to you last week. So what I'd like you to do is put 4 4s up on the board and put a little bit of space between them.
Okay.
And put an equal sign at the end. And choose a number between 15 and 20.
19.
Go ahead and make 19 the answer that you're looking for. So there's your challenge. I want you to see if you can use 4 4s, any mathematical symbols you want. Remember, square root symbol is 1, factorial is 1, decimal is 1, add, subtract, multiply, divide. All those they're all in play right now. So I want to see if you can get the 4 4s equal to 19.
What do you think?
It's going to be a challenge.
Yes, I agree. This is going to be a challenge.
Yes.
Now, obviously, we know that if we do multiplication, 4 multiplied by 4.
Now, if you get stuck, I can help you because I've already got a way to do it. But
Ooh,
I
okay.
need to see you guys go through this first.
Okay.
So if we have 4 times 4, we know is 16,
Yes.
right? So let's kind of talk through this.
Okay.
So we know that this is 16.
Yes.
So what we really need is this to get somehow to 3 more, right? So what do you think if, because we can't add 4 and subtract 4, can we?
Yeah.
Can't do that.
No.
We know that that would be 16, but if we times that another, what do you think?
Well, we could. Not really sure.
Yeah, I'm thinking too. We know, because last week we did square root, so we know that that equals 2, right?
Yes.
Okay. We need something that's going to cause this to be an even number. We also know that that equals 1. Okay. So how can we, what else?
We could add, divide, or subtract.
Right.
So.
We could do that. And we need to also think of our Pemdas. So your thoughts here?
Well, we could try adding and subtracting.
Okay, go for it.
Okay, so.
I'll take this away.
Okay.
Okay.
Okay, so we could try 4 plus 4.
Okay.
So over here, and then subtract it
Okay, so we have 8 here. 4 plus 4, we have 8.
Yeah.
Then you're subtracting 4?
Try this, girls.
Okay,
Let's start high. Okay?
so
How can you get a high number?
obviously by multiplying.
Right. So let's go with 4 factorial for the
Okay.
first one. So put the factorial symbol after the first 4,
ahead.
which means 4 times 3 times 2 times 1.
Okay,
Okay. Wait, do I just write it out?
Yeah.
Okay.
okay, so let's see what this is. That's 12, correct?
Yeah.
12 times 2,
24.
okay. Times 1
24.
is still 24.
Right. So
Okay,
you're going to start with 24. If you put 4 factorial,
okay,
you're going to have 24.
okay.
And you're going to be able to get down to 19 easier than trying to get up from 16. So what I'm going to do is I'm going to have you girls work on that for just a little bit, because right now we're going to go back out live to Seibert Elementary, visit with the Raiders, and see how they're doing with the Science for Kern and the mobiles that they're making.
Hey, thanks a lot, Mike. Back here at Seibert Elementary with Michelle from Science for Kern. Our challenge is wrapping things up, and you can't get them to stop. They're still making design changes. They still have those last little struggles. We want to test some of these out, and we're hearing we're not ready.
But I think I have one who might be ready.
Let's go ahead and take a look.
All right. So can I have this group right over here? Bring your car over to the testing track. Oh. And let's have it start on that fella.
I can't.
Put it down on the ground.
I got it.
And then you can tape it on again just a little bit. See if we can get it to stay.
Oh, I see what's going on.
And then we'll have the inflator get down there with it. No! Here we go.
Sorry.
That's all right.
Here, I see where it's coming out.
All right, make sure not to tape it to the ground.
It's coming out.
There you go. All right, turn it around. There you go. Turn it around. And we want to turn the car around the other way. We want the open end of the straw to face the inflator. All right, inflator. Get down there and let's see what happens. Let's see if it'll go. Keep going. Squeeze. All right, turn it loose and let's see what happens. Oh, that's all right. Nice try.
So, what do you think was the main issue with why this vehicle did not roll forward?
Because maybe the wheels.
So, what about the wheels do you think posed the challenge?
I think that there's too much tape right here on this side.
So, if you were to revisit this design, how would you change it for our next trial?
We would try to like not tape it that much, like make sure it's not on the bottom.
So, try to find a way to make the wheels round enough to actually roll. Okay, go ahead and see if you can work on that design. We have another design we're going to bring in that kind of took the idea that most of our groups had and kind of threw it around a little bit. Let's bring that in here. Now, a lot of the groups tried to attach a balloon to a straw. But this group recognized there's a part of the bottle that fits more readily around the mouth of the balloon. So talk a little bit about your design, about where you attach the balloon to.
Well, we
twisted
we
it.
accidentally broke it, so we figured out how it's kind of hard to move it around. So we basically kind of broke it to stretch it around the bottle, and then we glue through with Angel to where his face turned purple.
Lungs of steel. Oh my goodness, you should have seen this. Like, I thought he was about to hit the ground.
Yeah.
I blew so hard that I couldn't breathe no more.
You're not seeing stars or anything. You're okay. All right.
Yeah, all
And
right.
then we twisted it around, and after we taped it right here so it wouldn't go out.
So twisting the balloon allowed the air to stay in so that you didn't pass out.
Yeah.
So let's talk a little bit about what you predict is going to happen with this design.
Well, we're gonna predict that it might not move a lot because the tape around it.
Yeah, the tape didn't
But
really
this,
stay well.
it's holding it together and not allowing it to turn.
Okay.
Did you put your skewers inside
The straw,
clear
yes.
straws?
we
Can you-
did.
Why did you do that?
Because it was the only way we could stick it in.
It helps it rotate. If it didn't have the straws in, it would be like kind of getting stuck every once in a while.
So you feel like the wheels and the axles are going to be the challenge in its propulsion, but you feel like the balloon is going to provide enough energy to at least maybe move it a little bit. So let's see.
So if you untwist the balloon, will it go?
Yes.
It might.
Well, shall we try it?
Try to do it quickly so it doesn't release it all at once, right? Okay.
Let's see. Let's test it. Untwist.
She let it go, and a lot of it undid itself automatically, but there's still a
Do you
little
need to
bit
keep
left there.
untwisting?
Yeah.
Untwist a bit.
Twisted that very tight.
There you
Which
go.
definitely kept the air in that balloon, so it served its purpose. Okay, go.
Oh, that was way too.
So,
I'm not gonna blow that again. No.
yeah. I don't think anybody in our audience wants that.
Well, it did move like right here.
Okay.
Just barely?
What other challenges did you identify happening once the air in the balloon was released?
Well, one of them was the tape. It's like all around it and making it hard to move.
Okay.
If we just taped it right here and not all, like this, basically, it would have stayed.
Okay. Do you also feel that the direction of the vehicle would have propelled it forward with the air shooting out this way?
Yes.
Okay. Is there a possibility that it could have actually pushed it backwards this way
Well,
based on the force that was being exerted out?
yeah, but it looks like some of the air came out right here because there's little holes right here that we didn't tape in. But if we did push it this way, the balloon, it would have pushed the air outside, and then it'd try like moving, but
Okay.
it'd be kind of hard for it to.
So, if you had the chance to make a change to this design, what change do you think you would make as a group?
Take out the tape.
Okay.
And try and fix this because right now
we put too
easily
much
come out.
tape.
And maybe turn this around so that the air can come out this way.
Yeah, and
Right.
maybe let me blow it.
What do you mean by not so much tape?
Because the wheels, it makes it so taped around that it's kind of rocky. Like when if it did move, it'd be like right. If it was doing it right here, it'd be moving, but then like stop right here.
So do you think that this tape here is promoting movement or stopping movement?
Maybe stopping.
Well, thank you for your thought and for your work and design on this. We didn't have anybody meet the challenge, but the process over why things work and how they work, I think everybody leaves this room with a deeper understanding of propulsion and vehicular mechanics. So, great illustration with Science for Kurt. Michelle, thank you so very much.
Thank you, my pleasure.
Mike, we're going to go ahead and send it back to the studio. Have a great evening. Take it away.
All right, thanks for that. Nice to see all of the Raiders out at Seibert Elementary working with Science for Kern, Michelle, and Devin out there. In studio, we have Julie. Why don't you go ahead and show us how you guys finally solved this problem?
Okay, so basically what we did is we did the
4 factorial.
yeah, the 4 factorial, which equal 24.
Quickly, and then we subtracted 4.
Yes,
Which
that-
equals
20.
20, and then 4 divided by 4 is?
1.
There you
And
go.
20 minus 1 is?
19.
And until we
Awesome.
meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District. with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.